Now we shall talk about the non-homogeneous equation. A non-homogeneous equation of the kind ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Why it is non-homogeneous? The degree of first three terms is 2, but remaining degrees are not 2. If the degree is same, then only it is called homogeneous. So this type of equation, what does it graphically represent? If I plot the graph of such an equation, what kind of graph I get? That's what we are learning here. You know that this particular equation can represent circle, parabola, ellipse, hyperbola, pair of lines. Any curve in two dimensions can be always represented by this equation. Depending on the value of a, h, b, g, f, c, it varies. So our question now is, when will this equation represent a pair of lines? What is the condition for this equation to represent a pair of lines? I added an extra module to prove the theory behind it, but you need not learn those theory, but just to understand the theory, I have put it. Anyhow, let me explain to you. This equation represents a pair of line if the determinant, we denote the determinant by delta. Determinant's first row is obtained by collecting the alphabets of x terms. Terms containing x. The first alphabet A, second alphabet H, third alphabet G. Now take in the same order y's coefficient. H here, B here and F here. So H, B, F. Then take the last three, G, F, C. X coefficients alphabet, Y coefficient alphabet and last three alphabets gives you the determinant. If this value of the determinant 0, then this equation would represent a pair of line. Now to remember this, I can also give you another method, the expansion of this. The expansion of this, what are the alphabets that we have in it? We have A, B and C. Then there is no D here. Then we have F, A, B, C, D, F, G, H in order. A, B, C, D is not there, F, G, H. Write the alphabets in order. Then the first term of this expansion will be the product of the first three alphabets, A, B, C, plus product of this two multiplied with 2 F, G, H. Then minus A into square of this, AF square, minus BG square, minus CH square. If this expansion is 0, then this equation would represent a pair of lines. So we need to learn by heart these two things. Either by heart this determinant, determinant should be by hearted. We need it for remaining part also. This is to be by hearted as an expansion. Whichever is more convenient, you can use it. So whenever I want to test such an equation represents a pair of line, what should I do? Calculate this determinant, check whether it's 0. If it is 0, it represents a pair of line. Otherwise, by heart this statement, substitute A, B, C, F, G, H value in it. If you get the answer 0, then also it represents a pair of lines. The next point I want to explain to you is, suppose I collect the first three terms. What are the first three terms? Ax square plus 2hxy plus by square equal to 0. Imagine equation 1 represents a pair of line. Equation 2 also represents a pair of line. Will these two equations graphically have any relation? I am just going to show you what is the graphical representation of the both equations. Remember this, the coefficient AHB remains the same. The coefficients remains the same. First I am drawing the sketch of the first pair of lines. I am assuming this is representing a pair of line. If it represents a pair of line, let's imagine to be like this. Let's call this as L1 and this as L2. Then if I want to sketch the equation represented by this, the pair of lines represented by this equation, equation 2, then I should draw a line parallel to L1 passing through the origin, something like this. This L1 dash is passing through the origin and parallel to L1. I need to draw L2 passing through the origin and parallel to L2. This is L2 dash. L2 is and L2 dash are parallel to each other. L1 and L1 dash are parallel to each other. This represents this equation, then this will represent this equation. So what is the benefit? If I want to calculate the slope of the lines represented by this equation, I need to calculate the slope of the line represented by this, because both of them have the same slope. And how do you calculate the slope of this line? By solving the equation bm square plus 2hm plus a equal to 0. What do you call this equation? The auxiliary equation. If I solve the auxiliary equation, whatever the value of m I get, there will be the slope of L1 dash and L2 dash, hence there will be the slope of L1 and L2. If I want to find out the angle between them, I need not to find the angle between this pair of line is same as finding the angle between the pair of this line, because both angles are same. Hence I can use the formula tan theta is equal to 2 root h square minus ab upon a plus b. The same formula that we applied in case of homogeneous equation. When will this line be perpendicular? When a plus b is 0. So when will this line be perpendicular? When a plus b is 0. When will this line be coincident? When x square minus ab equal to 0. When will this line be parallel? When x square minus ab equal to 0. So this equation represents a pair of line. If the determinant is 0, angle between the lines is given by this formula. Condition for the lines to be parallel. Condition for the lines to be perpendicular is a plus b should be 0. And finally, if I want to find the slope of the lines, solve the auxiliary equation bm square plus 2hm plus a equal to 0, I'll get the slope of the lines. So we can easily calculate the slope of the lines by using this. Lastly, I want to find this point of intersection. Remember the determinant AHG, HBF, GFC. This is the determinant that we had. Create two linear equations using the first two rows, AX plus HY plus G equal to 0. Another one, HX plus BY plus F equal to 0. Solve these two equations simultaneously, you will get the point of intersection. This is the formula you can by heart if you feel like by hearting. Bg minus hf upon x square minus ab will be the x coordinate of the point of intersection. Af minus gh upon x square minus ab will be the y coordinate. If you feel difficult to by heart all this, just very easy to remember. Formulate a linear equation with the first row, formulate a linear equation with the second row, and solve them. Or correct the alphabets with the coefficient of x, correct the alphabets with the coefficient of y, and then make them two linear equations, solve simultaneously, you will get the point of intersection. The first problem, we need to show that this equation represents a pair of straight lines. That's the first part of the question. When they represent a pair of lines, you need to find out what is the acute angle between them. You also need to find out what is their point of intersection. So the first part, we will check whether this equation represents a pair of lines or not. When will this particular equation represents a pair of lines? When the determinant is 0. Now we are going to calculate the value of the determinant of this equation. We usually denote the determinant by the notation delta. So is delta 0 or not, we are going to check. First, let's calculate the value of A, H, B, etc. How do you calculate A, H, B, G, F, C, etc.? By comparing both the equation. Coefficient of x square is 1 here, so A's value is 1. Here the coefficient of xy is 2h, but here it is minus 6. We need only the value of h. So h will be half of minus 6, that is minus 3. Or in other words, 2h is minus 6, so h is minus 3. B's value would be, B is the coefficient of y square, so which is 5. Then comes to G. If you compare, 2G is 10. So G is half of 10, that is 5. 2F is minus 14. So F will be half of minus 14, which is minus 7. And the constant term is 9. So we got all the data that is required. Now we will calculate the value of the delta. So the value of delta is A, 1, minus 3, and G, 5. Usually what I do is, I just look at the x term. A, 1, half of it, minus 3, and half of it, 5. So A, H, G. Next is H, B, F. H is y coefficients in order, but this will be half and this will be half. So you will get minus 3, 5 and minus 7. Again, the last three term, G, F, C, 5, minus 7, 9, or you may take like this, half of it, 5, half of it, minus 7 and C fully. Now we'll calculate the value of this determinant. So 1 into 5 into 9, 45, minus 7 into minus 7, so 49. Then the second term should be taken with a negative sign. First term with a positive. Second should be taken with a negative sign. So it is minus of the minus number 3 in the bracket, minus 27 plus 35. Last number 5 with positive sign, 21 minus 25. 21 minus 25. I hope once again I explained to you. Start with 1, delete the row and column containing it, 45 minus of 49. Then next number should be taken with a negative sign, but the number is also having a negative, so the ultimate will become positive. Then delete the row and column containing it, so minus 27 plus 35. Then third number 5 with positive sign, delete the row and column containing 5, so 21 minus 25. So which will give you 45 minus 4, and this will give you 8, 24, and this gives you minus 20. So minus 4 minus 20 minus 24 plus 24 will give you 0. So the value of the delta is 0. Hence I can say this equation represents a pair of lines. So when you calculate the value of delta, be careful how to expand it. You can also use a property, R2 minus R1, R3 minus R2, that determinants property. If you use and show that two rows are identical, it will be much faster to calculate than expanding. That is your choice. Now we will find the angle between the lines. And angle between the lines is given by the formula tan theta is equal to 2 root h square minus AB upon A plus B. Before you start, just check whether A plus B is 0. If A plus B is 0, directly you can say the lines are perpendicular. Since here A plus B is not 0, so we will calculate it. So modulus of 2 root h is minus 3. So minus 3 square minus A is 1, B is 5. So 1 into 5 upon 1 plus 5. So that became modulus of 2 root 9 minus 5 is 4 upon 6. So that became 2 into 2, 4 by 6. That is 2 by 3. So I can say the angle theta, the acute angle theta is tan inverse 2 by 3. You must have noticed that we have calculated the acute angle because we have taken the modulus. So theta is tan inverse 2 by 3. This is the acute angle between the pair of lines. Now we will find the point of intersection. Point of intersection is obtained by solving these two equations. Remember how to formulate the equation: A coefficient of x, h coefficient of y, coefficient of xy, and g from here. So A is 1, h will be half of this, g will be half of this. So we get x minus 3y plus y equal to 0. Then we get the equation, second equation, h, b and f. This is minus 3, this is 5 and this is minus 7. Now we need to solve this linear equation. After solving the linear equation simultaneously, you will get the coordinate. Therefore the point of intersection is 1, 2. So we have found out, first we showed that this equation represents a pair of line by showing the determinant is 0. We found out the angle between the lines by taking tan theta is 2 root h square minus AB upon A plus B. I told you that before you start that, test whether A plus B is 0 or not. Then we found out the point of intersection by solving the two linear equations obtained by A, H, G, H, B, F, the same two rows of the determinant, and we got the point of intersection as 1, 2. Now we have the second question. This equation represents a pair of perpendicular lines. First of all, it represents perpendicular. Second, perpendicular lines. So two conditions to be applied. First condition, A plus B should be 0, from which we will get P's value. Then we'll apply, it represents a pair of lines, so determinant should be 0. So the first condition we'll apply, their lines are perpendicular. lines are perpendicular if a plus b equal to 0. That is 2 plus minus p should be 0. So p's value should be 2. Now we'll apply the delta is 0. What is delta? A, H, G, H, B, F, G, F, C should be 0. Remember, now the p's value is 2, so your b will be, now let's compare and write. If I compare with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, a is 2, h is half of 4, b is minus p, but p is 2 here, so b will be minus 2, then g will be half of it 2, f is half of it q by 2, and c is 1. Now we'll apply the determinant. Determinant is 2, 2, g is 2, so the first row all are 2, 2, 2. Second row h 2, b is minus 2, f is q by 2, then gfc 2, q by 2 and 1. This should be 0. Now to solve this equation a little more easier way, one method is you can just expand it and get the answer. Second, you can take a 2 common from the first row, and if you want you can remove this 2 by multiplying with 2, etc. But let me just directly do, the numbers are very small here. So 2 into minus 2 minus q square by 4 minus 2 into 2 minus q plus 2 into q plus 4 should be 0. Once again let me check. 2 into minus 2 minus q square by 4 minus 2 into 2 minus q, 2 into q minus of minus plus 4. So minus 4 minus q square by 2, again minus 4 plus 2q plus 2q and plus 8. So 8 will get cancelled. So I have, let me take the LCM, minus q square, 2 plus 2, 4 plus into 2, 8q should be 0. So taking q common, minus q plus 8 should be 0, which means either q is 0 or q is 8. So my answer is, for this equation to represent a pair of line, p should be 2, q can have two values. Even if q is 0, you will represent a pair of perpendicular line. Even q is 8, it will represent a pair of lines. Hence there are two answers at q, whereas p has only one answer. Now this is a different problem, but the question remains the same. The question is, show that this equation represents a pair of lines and also find the point of intersection. If you expand this, it is of the same format, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. Same format if you expand. But it is already given in a very simple format. We need to show that this represents a pair of line. What you do is, looking at this equation, if I shift the origin to 1 comma minus 2, here I took positive 1, here I took negative 1. If I shift the origin to 1 comma minus 2, the new equation is obtained by replacing x by capital X plus 1 and y by capital Y plus minus 2. That means it will become minus 2. Then this equation would become, if I replace capital X plus 1 here, capital Y plus 2 here, this equation automatically become 3x square minus 4xy plus 5y square equal to 0. That means after the shift of the origin to 1 comma minus 2, axis drawn parallel to the original x-axis and y-axis, then this equation is converted to a homogeneous equation. Hence this represents a pair of line. Therefore the original equation also represents a pair of lines. So what we'll say after this, which is a homogeneous equation of second degree. Hence equation 2 represents a pair of line. So naturally, the equation 1 also will represent a pair of lines. The point of intersection of this line is origin, and we have shifted the origin to 1 from 1 comma. We have shifted the origin to 1 comma 2. Therefore, the point of intersection will be the point where the origin is shifted, which is nothing but 1 comma minus 2. So you can just look at it and say your answer. By shifting the origin to 1 comma 2, this equation becomes homogeneous equation of second degree. Hence, it represents a pair of line. Therefore, the given equation also represents a pair of line. And wherever we shift the origin, that is the point of intersection of the pair of lines.